Hi all, this is the practice problems 15 from our trig derivatives. We were going to go over these in class today, and I'm not going to be there, so this is a chance for you to see how they're done. So let's take a look. Number one, you have a 2 in front of the sine x, so that's not a product rule because it's a constant. So that's just going to give me f prime of x equals 2 times the derivative of sine, which is cosine x, minus the derivative of cosine x is negative sine x. So this is 2 cosine x plus sine x. And that's my answer for 1. Number 2, we're in the same kind of boat, except that this is the sine of something other than just an x. So I'm going to think about this as 5 sine of 3x plus 1. So again, the 5 out front, I don't worry about that. We're going to leave it there, and we're going to differentiate the sine function. But with this one, I have an inside function and an outside function. So we're going to use chain rule. And that means that the derivative is we leave the 5, take the derivative of sine, which is cosine, leave the inside alone, and then we multiply by the derivative of the inside, which is 3. The derivative of plus 1 is 0, so I don't need to write that one. And so if I put the 5 and the 3 together, that gives me 15 cosine of 3x. And that's my final answer. Okay, so when you have the sine or any trig function of something other than x, you need to make sure you use chain rule. I like to put the parentheses around the argument, and so that signifies to me that that's my inside. All right, next one, 7 times the sine squared x. I'm going to rewrite this one again. We're going to leave the 7, and I'm going to put the 2 on the outside. So this is sine x squared. And that indicates to me that I need chain rule. The sine x is on the inside, the square is on the outside. So when I take my derivative, I leave the 7, bring down my 2, leave the sine of x, decrease the power by 1, multiply by the derivative of the inside, which is cosine x. So this will be 14 sine x cosine x. Number 4, here the x belongs to the cosine, so that's all one term. And then this is a second term, so these two are being multiplied together. So this is function 1, and this is function 2, so I'm going to use a product rule. So function 1 is the cosine of x, and its derivative is negative sine x. Function 2 is x cubed minus 1, and its derivative is 3x squared. So when we take our derivative, put this together using our product rule. So 1 prime 2 is negative sine x times x cubed minus 1 plus 3x squared times the cosine of x. Okay. Next, okay, let's see if we can decipher this one. So it appears as if I have two things that are being multiplied together. I have the cosine of 4x as function 1, and then this whole set of parentheses is my function 2. Inside of that, my term 1 has a 4x on the inside and a cosine on the outside. And function 2, I have a sine on the outside and a 2x on the inside. All right, so let's tackle each of these individually. So function 1 is the cosine of 4x. And when I take its derivative, the derivative of the outside, which is the cosine, is negative sine. Leave the inside alone. Multiply by the derivative of the inside. So that's negative 4 sine 4x. Function 2 is the sine of 2x minus x. So when I go to take the derivative, I take the derivative of the outside function, which is sine. So its derivative is cosine. Leave the 2x. Multiply by the derivative of the inside, which would be 2. Minus 1. So this is 2 cosine 2x minus 1. And then when we, put together our derivative here, this is f prime of x equals 1 prime 2. So negative 4 sine 4x times the sine of 2x minus x plus 2 prime 1. So cosine of 4x times 2 cosine 2x minus 1. And to be honest, I'm going to leave it just like that. If I were to distribute, I'd just end up with more terms and more things to write. None of them will combine. None of them are squared. Keep in mind that you have different trig functions with different arguments here. But please note, as I took each derivative, the argument didn't change. If I started out with a 4x inside my cosine, I should end with a 4x inside whatever trig function I'm working with. Okay. On the right with function 2, it was a 2x and it remained a 2x. Number 6. You can see right away we're going to be working with quotient rule here. So the top is tangent x, and its derivative is secant squared x. The bottom is the x cubed plus 3x squared minus 4, and its derivative is 3x squared plus 6x. So when we put this together using our derivative, using quotient rule, that's top prime bottom, so secant squared x times x cubed plus 3x squared minus 4 minus bottom prime top tangent x times 3x squared plus 6x all over the bottom squared, so x cubed plus 3x squared minus 4 squared. And again, if you were to distribute that to each term, I can't combine anything because the sorry about that. Everything in the first term is multiplied by secant squared. Everything in the second term is tangent. They're not going to be like terms, so we're going to leave it just as it is. And lastly, number 7. We have an inside function, that's the cosecant x plus x, and an outside function, which is the cube. So when we take our derivative, this is f prime of x equals, bring down your 3, leave the inside alone, decrease your exponent by 1. Okay, that's the derivative of the 3. Then we multiply by the derivative of what's inside. The derivative of cosecant is negative cosecant x cotangent x, plus the derivative of x is 1. And again, there's not even anything for me to combine. I'm just going to leave this like this as is. And that's